This video shows how to use de Moivre's theorem to find powers of complex numbers. This technique appears frequently on algebra and pre-calculus exams and provides a foundation for advanced topics like signal processing. You'll learn to convert to polar form, apply the power rule to both magnitude and angle, and connect trigonometric and exponential representations. We'll convert 1 plus I to polar form, getting r equals root 2 and theta equals pi over 4. Then we raise r to the 8th and multiply the angle by 8. Both de Moivre and Euler give us the same answer, 16. Let's work through it on the diagram. How do you raise 1 plus I to the 8th power? Multiplying it out algebraically would be painful, but in polar form it becomes one clean step. Students often try to expand the binomial. The trick is to see complex multiplication as rotation and scaling. That's exactly what de Moivre's theorem captures. Goal: convert 1 plus I to polar form. Apply de Moivre's theorem to compute the 8th power and see how Euler's formula provides the compact notation. Step 1. To convert a plus bi to polar form, find the modulus r and the argument theta. The modulus is the square root of 1 squared plus 1 squared, which is root 2. The argument is arctan of 1 over 1, which is pi over 4, or 45 degrees. So 1 plus I equals root 2 times cosine pi over 4 plus I sine pi over 4. In Euler notation, that's root 2 times e to the I pi over 4. Now we apply de Moivre's theorem to raise this to the 8th power. Step 2. De Moivre says, raise r to the n and multiply the angle by n. We substitute the polar form, root 2 times e to the I pi over 4, all raised to the 8th. Separate into r to the 8th times e to the I times 8 times p over 4. Root 2 to the 8th is 2 to the 4th, which is 16. 8 times pi over 4 is 2 pi. That's a full rotation back to the positive real axis. Cosine of 2 pi is 1. Sine of 2 pi is 0. So the answer is simply 16. Let's see why Euler's formula makes this even more transparent. Step 3. Euler's formula tells us e to the I theta equals cosine theta plus I sine theta. This is the bridge between exponential and trigonometric forms. Euler's formula encodes both cosine and sine into a single exponential. Raising re to the I theta to the nth power is just r to the n times e to the I n theta. Ordinary exponent rules. No trig identities needed. For our problem, 16 times e to the I 2 pi is 16 times 1, giving us 16. Euler makes de Moivre automatic. Whenever you need to raise a complex number to a large power, convert to polar form first. Find the modulus and argument, then apply ordinary exponent rules. De Moivre and Euler both say the same thing. Scale the modulus, rotate the angle, re to the I theta, raised to the n equals r to the n times e to the I n theta. One formula, no trig expansion needed.